So, data frame. What did we discuss about data frame? Yes, Amina.
Okay, hope you can hear me.
Yes, loud and clear.
Okay, data frame is a special list that store values of different types.
That is very nice. That is very nice. Madam Amina she's saying that a data frame is basically a special list that stores data of different type, which is very correct. That is what we said last time. So basically, a data frame is heterogeneous. If you remember, we were classifying and we were saying we have homogeneous data structures and heterogeneous data structures. So a data frame is a perfect example of a heterogeneous data structure. Now again, remember I was saying that it is one of the common type of data that we'll be dealing with in our day-to-day analysis, or as far as R is concerned, that we will always be having a data frame. We'll always be dealing with, in most of the cases. So a data frame is a list of vector such that each vector contains the same data type, but now different vectors store different data types. You remember when we were saying a vector is a collection of elements that is of the same type. Now we can have one vector that is storing, let's say, numerical, another one is storing characters, and another vector is storing logics as data types. Now when we put them together, they form a data frame. They form a data frame. So unlike matrices, where we were looking at matrices as row and column arrangement, so we are looking at a data frame as a collection of different vectors storing different data structures. Now we said to form a data frame, we need to use a function, and that function is called data.frame. So let's just say we are discussing data frame, or rather data frames, and we are saying to form a data frame we use the function data.frame. So the other day I was giving this example of saying, suppose we have a data frame called data. We have a data frame called data. Now this data, because it is a data frame, a collection of vector, we need to form it using the function data.frame. Just like when we were forming lists, we were using the word list. Now, once you have that function, you now list your vectors in that bracket. That is where you list all your vectors separated by a comma. Remember, data frame is a collection of vectors. So suppose we have data about a particular individuals, where now we are trying to store information about these individuals. Let's say I'm conducting a study of, let's say, a sample of students. Now maybe I need to record their age, their height, and their weight. So I'm entering that information in R. Now I can use a data frame because I have three vectors one storing the age, other one storing the height, and the other one storing the weight. Now, one thing that you need to take note here is that age is of, let's say we also have another vector that is storing the name. Actually, let's say we have another vector that is storing the name of the particular students. So we have four vectors. So one is the name of the student, the other one is the age, the other one is the height, and the fourth one is the weight. Now in this case, you realize that age is character, name is character, sorry. Now weight, height, and age are numerical. So you look at them as vectors, and each vector is of the same data type. But now collectively they are of different, because name and age are of different data types, but they are stored, or rather they are stored in the same data frame, that is data. There is one aspect that you need to understand. That is why in the definition we are saying a data frame is a collection of vectors, where now the vectors themselves now are storing elements of the same data types, but each vector can store elements of different data types. As when we compare this vector and the other one, the elements can be different. Now, another important aspect that you need to understand about data frame is that the components, those components that are forming the data frame, they need to be of the same length. That is, if I have 10 names of students and under the vector name, then I need to have age of 10 students, height of 10, and weight of 10, such that if I have 10 names with 8 weight and 8 values of representing the age, that will not form a data frame. It must be of the same elements. So a very quick example, let's say we have n to represent the name, So I'll say n. Now because we have several students, we'll use the combine function. Now because the names are characters, I will have to quote them. So let's say I have Ali as the first. Where else can I get names if not here? I see from my list I have Amina. I also have Saif. I also have, the other one is you. It's telling me you, okay? We have Mary. We have Mary. We also have Moses. We have Moses. Saif, you are speaking. Okay, it is just on. So we have Moses. That is the name, or rather the names. Now, those are elements of the vector. The vector is a part of the data frame, is an element now for the data frame. So I need to put a comma there so that I can list the other component of the data frame. Now the other one is weight. So I'll say the weight using the combine function. Let's say the first is 68, or that is 58, no problem. Then let's say 60. This is random. This is not in, I'm just putting the weight random, so don't take it personal. Let's say we have 63. Let's say we have 64. let's say 58, and lastly 60. I hope those are in number, I mean the number is equal. Let me hope so. Then we put a comma, and now we list the other one. So let's say the other one is age. Let's say age, and I will also use a combined function because we are looking at them for a number of them for various observations or respondents. So let's say 25, 22, 23, 25, and 26. And 26. I hope they're also these are 5 on the other one. Am I having less? How many names are here? We have 5 names. These observations are 6, but all the names are 5. So we need to remove one from here. Remember, must be of the same length. Now we run that, and I have my data frame. So I've stored the name, the weight, and the age of these respondents, such that if I call my data and say data, and I run that, you can see it is listed. I have n, that is the names, weight, and their age also. So that is a data frame. That is a data frame, and how we form a data frame. Very important is to know that the elements need to be of the same length. That is very important. And you see, these are vectors, but not the first vector. The data type of the first is different from the second. So unlike matrices, which can thought be of vectors arranged in rows and columns, a data frame is not required to have the same data type like in those matrices we were discussing. So another important aspect that we were discussing last time is subsetting elements of a data frame. How do we access the elements of a data frame? Now, I showed you a number of ways. So which one do you remember? There were a number of ways we were talking how we can subset or rather access the component of a data frame. Like for instance, from this data frame data, the name of the data frame, because it's data, we have assigned all this to data. That is why when I call data, it is listing all this. So suppose I only want to access the names without the weight column and the age column, just the names. How do I access that? What are those possible ways that I can access? I remember we had also talked about this. So which one do you remember?
Use of $sign.
That is nice. Mary is saying the use of a $sign. We can actually use the operator to access the element of a data frame. So maybe you give us an example, Mary. Suppose you want to access weight. How do we do that?
Okay, data. $sign. You said age?
Yes.
Age,
which is A. And when I run that, I'm getting the age. So there is one way we can access the elements of a data frame. So when I say data, and by the time I put a $sign, you see all the components or the elements are listed. So when I say n, it will give me the names. Any other approach that you can remember that we discussed last time?
We have the index method.
Perfect. We have the index method where we can access the element using the index. Some books will say the address of that particular element or component. So maybe you give us an example, Mr. Moses.
Yeah, so an example, like you say data, then those angular braces, then inside you put the index, like the position, whether it's the first one, the second one, or the third one.
So assuming I want to access the names.
So if it's accessing the name, then we'll say data, those angular braces, then one.
One like that.
Yeah.
And when I run, it is giving me the names. That is perfect. So you use the name, you need the name of the data frame, and then in a rectangular bracket, you put its position, or rather the index. So if I want age, I'll say 3, and it will give me. How about when I say data, and I have 2 brackets instead of 1, and I say 2? What is happening? It is also giving me the desired output. So you can actually use 1 or double, still to give you the same. Any other approach that we discussed? I remember we discussed another approach. There are several. There are actually several. I don't think we'll finish them in this session, but some of them, you will learn them as we advance. Now, any other approach that you can remember? Now, we use the function. I remember we talked about a function, and the name of the function is attach. I remember saying it's like, and I was even saying, if you don't understand a function, kindly ask for help using the question mark before. Run that, and you will get the help here. So attach set of R object to search path. So it's like we are taking the data set when we are attaching it, making it readily available so that whatever element or something that you will ask for will just go and check on that specific attachment that you have passed to the attach function. So we can actually use the attach function, and when we do, like for this case, I say attach the data frame, which is data, and I run that. So everything about, every information about data as a data frame is already there and readily available, such that if I do anything that is in relation to that data frame, then it will go check if that information is there and return the desired output. So when I say n and I run that, because I've attached the data frame, it will go and check if there's anything that is related to n as far as the components are concerned, and return what is being represented by n. So when I say w and I run that, we will have the values also there. We'll have the values there. So that is also another approach, another basic approach that we'll be using and doing our analysis. But most importantly is the pipe operator. We will be looking at the pipe operator, which is like attach but is different because it is taking something, make it readily available for the next analysis that you're going to do or operation you're going to do. So we'll also discuss the pipe operator. But before we do so, I hope you understand these 3 approaches, these 3 basic approaches. Using the $sign operator, using the index method, and using the attach function. So any questions so far? Any questions so far? any point that is not clear? Yes, Amina, kindly ask.
Okay. Could you please run that for after the command attach? Could you please run that for A?
I ran
Because
for
on my
A.
side it is giving me 5, yeah, and it's supposed to give me the edges.
There is the one for A.
Why is it giving me 5?
No, it's not supposed to give the number of observation, but rather to list them. Now, what you do,
Yes.
rerun the command attach, rerun the function, and then just run for A. Yes, someone's hand is up. Sorry?
It's still giving me the same result.
Someone was also raising his or her hand. I didn't see that. You are saying it's still giving 5?
Yes.
Okay. And you have attached the data.
Yes.
And run for A is giving 5.
Yeah, but the other 2 are okay.
Now let me ask you, did you assign using equal to or less than?
Data or the
Here,
and
for the names of the, for the vectors.
I've used equal sign.
You have used equal sign.
Yes.
Now try and change that. There are several reasons as to why. Oh, what's happening? Okay. Oh yeah. So, have you tried to change? Did you change the assignment for A?
No.
Sorry?
Please.
Okay, just change for A alone. Rerun for the data frame. Come run for attach and run for A.
I have it.
Yes? It's giving
I
you.
have it. Yes.
Okay. Okay, there seems to be a network issue from my end, but I hope you can hear me. So I was saying, the reason as to why I'm showing you all these methods of accessing the element of a data frame is because at times it's not always that one method will work out because of some. Mary, do you have a question?
No.
Okay. So I was saying that it's not always that all of them will give you the desired output because of some petty issues and all that, which at times they are very hard to identify and try to correct that. Like look for that instance where for Madam Amina, she was having the 2 but not for A. And only changing the assignment has resolved that. So at times it will be very hard to determine. Now because of that, it is the reason as to why we have these various methods so that you can access the elements. Once you find that this one is not giving the desired output, maybe there is some issue with the data, maybe assignment, maybe during importation. Remember, we'll be importing data and all that. But most importantly is that they will always work out. They will always work out. That is the fact. So it's just a matter of mastering them and learning when to use which one depending on the situation and the type of analysis you are going to do. That is one. And two, there are several other approaches that we might not discuss here, but they are commonly used and we'll be using them as we proceed, like the pipe operator, which works. So, okay, in this context, I can say just like the attach, making everything available for the next that we're going to do. So we'll also discuss that. Now, I also remember the other time I was creating a data frame using a function, and I was saying it's not always that you are limited to have the data like this. For this academic purpose, at times I'm given maybe a report, maybe an analysis. Someone is doing masters and all that and want to have a good report. So you see, for such a case, this one guy doesn't have a data for that particular analysis that is to be included, but the research need to be done. And you see, a research you need to go and collect data. That is the fact about the research. But now, because of issues and all that, you'll be forced to cook some values. So you'll need to generate data set for the various variables that are there. So as you use data frame, it's not always that you'll be listing. Imagine I need to have age for 500 people. The sample size is 500. So if I'm supposed to generate that, then I'll use a function and all that. That is why last time I was also having a data frame that was actually representing, was generated using function. And I was saying, suppose I call data frame my data, and now I form the data frame by the function data.frame. So I was saying, let's say that x is the numbers. I'm using a concatenating function. That is 1, 2, okay, let's say 3, 5, 7 to 9, and then that is repeating again. And I was having 1, 3, 5, 7, and 9. And I remember I was asking you, there is actually a function that we can use that can generate that number, because this is a sequence that is increasing by 2, starting from 1 to 9, and then the sequence is repeated. So I can use repeat the sequence and all that, and I'll have it. I guess we discussed that last time. That is why I'm not so much into it. So we were also using the repeat. We're using the repeat function, and we were saying repeat hello, and we were to repeat this 9 times. Remember, the length need to be the same, and we were saying good, let's say good night or goodbye. This is short. Then I put a comma, and maybe we have Z, the last one, and now let's say Z is basically a repetition of the combination of the two logics. That is true, and false, and false, and false, and we are repeating this 5 times. So we were running this so that when I call my data, we have it x is 1 to 9 and then repeated, y is hello, and the last one is goodbye, and z is a repetition of true, false 5 times. So that is basically, you can use a function as well. Now to access these elements, we have mastered that. we were looking at the length of these particular elements, and when we were doing so, we were actually using the function called all equal. I remember we were discussing about this, and we were saying it will return true if the values is the length is actually equal. So we are saying all equal, then we are saying the length of this, comma length of the length of x, comma length of y, comma length of z, and it will return true if all that is true. Now, one function that we will be mostly using in most of the cases is what we call the structure function, and we will always use this function. Now, this one function will display the structure of the data set. Suppose we have imported our data set. Now we want to see this data set that has been imported. What is its structure? Is it a vector? Is it a data frame? Is it a table? Is it a list? So the structure function now can be used. So when I say the structure of my data, it will be able to tell me. Now, one thing about the structure function, it will return the data structure of that particular data set, the number of observation, and the number of variables. And also, each variable, its data type, and maybe some few elements of that particular variable. So when I run that, you can see here, I have the structure as a data frame, and in this data frame we have 10 observations with 3 variables. Now we have x, which is numerical, y is character, and z is logic. And I was saying actually this information that we're getting here is actually available on the environment. Is also available in the environment. You can see we have x here, we have z, and we have our y. We have them here. Now, that is one function that we are going to use. Or maybe at times, we are not interested, we only need to know the number of observations. Now, those are the rows. So we were using the n rows to display that. So when I say n rows of my data frame, it will return the number of observations. So I know, oh, I have 10 observations. As well, when I say n columns to know the number of variables, remember the number of columns represent the number of variables, and the number of rows represents the number of observation. So when I say n column of my data, it will now return the number of variables that are there. Those are some of the functions that we will mostly use. As well, we can use the dimension to obtain the two. That is the number of rows and the number of columns. So when I say the dimension of my data, it will give me the number of observation and the number of columns respectively. I think that is what we discussed last time. Now I was saying using the data.frame function is one approach of importing, of creating a data frame. That is one approach. But actually, there are several other approaches that we can actually create a data frame. And one of them is through importing data. When we import our data, in most of the cases, the data imported will be in form of a data frame. And in most of the cases, we'll be given a data maybe from SPSS, not SPSS. In most of the cases, not SPSS, but in Excel. We will always be given data in Excel. So we will be required to import that data now to R from the Excel file. How are we going to do that? Now, when we do, you realize our data will be stored as a data frame. So now we need to know how to, that is why we need to know how to manipulate a data frame, like accessing the elements and all that. So I was also saying last time before I went off that we have some functions that we can use to read an Excel file. You see, importing data, you are reading a file from another source now to what is called reading. So we are saying that to read a file or an Excel file to be specific, we use the read underscore CSV function. Read underscore CSV function. Now we were saying this function, I'm just showing the function, but I'm not actually implementing the function. We'll do that. We were saying that, sorry for that. This function, this one function, is found in the library called readr. Is found in the library called readr. Now, remember the time when we were introducing R, we were talking about libraries and packages. We were saying a library is a collection of functions and data sets that will be made available for the user so that we can use them. So this function is found in readr. So in order to use this function, we must first have installed the package readr and again load that package. Remember we said if you want a book from the library, I'm looking at a function as the content in that book. So if you want a book from the library, you want a content actually to read and understand that content. And the book is in the library. First, you have to move from where you are to the library. That is now installing the package. Then after doing that, you also need to, when you get to the library, you need to take the book from the bookshelf now, sit with it, open the book and start reading. That is now loading the library. That is now loading the library. So to use this function, read underscore R, we need to have installed the library readr. But there is another function called read.csv. This function. Now this function is under the package utils. You can see when we were saying read.csv, you can see utils. This is the package where this function resides. Now this function, this package, this one library, will automatically be installed as R is installing because they are basic functions that we always interact with. Just like the library base R, it will also be installed as we install R. Now, I was saying, in most of the cases, we'll be using the function read underscore R instead of read underscore CSV instead of the function read.csv. And I was saying the reason is the read underscore CSV has a number of advantages compared to .csv. And two main advantages is that the read underscore CSV is very fast when we are importing a large data compared to read.csv. That is one advantage. The other advantage is that the read underscore CSV will automatically and by default use what we call table package to read the data as a table. To read the data as a table. I say table. This is the term. You can see that. Now, a table is basically a data frame. Someone once said a table is basically a data frame that is displaying information with sanity. It prints with, it's more organized. It's a data frame that is more organized, well structured. So that is why in most of the cases we'll be using the read underscore CSV. The read underscore CSV. So because of that, I want us to to import our data. There's data I shared sometimes back. The name of the data is called data. This is the data that I'm talking about. This is the data that I'm talking about. Now, one thing that you need to know is that a CSV file is not an Excel file. Is not an Excel file. We talked about that. So there's this data I shared, it's called data. So if you don't have the data, kindly let us know so that we can forward the data to you very fast. But otherwise, I hope we all have this data. So first we need to check the data. We see how the data is, so that by the time we import our data, we have an idea of how our data looks like. So let's just give it time. But basically, as we're giving it time, going back to R, as I import that data, when it comes to my R, I need to give it a name. Remember, it's a data frame. And to access the elements of the data frame, you need to have the name of the data frame. So I can say, or I can give it a name. Okay, the data set is open, or rather opening. So this is the data set we are talking about. You can see the data set is having, what was that? We have weight, we have the quality, the color, the price, the length, the width, and the depth. That is what we wanted to see, only that. So let's just go back to our R and we'll start importing our data. Now I was saying that we need to give it a name. So I can call it data1 because already there's data, and we give it a name. Oh, one important thing, sorry for that, we said you'll be using the read underscore CSV. Now to do that, we first need to load the library. So load, library read R. Library read R. I hope last time we installed this package read R. So when I run that, you see there is no error and there is nothing. It means it has been loaded. So now I'm reading my data. So we need to give it a name. I'm calling it data1. Then I write read underscore. And by the time I put an underscore, if the library was loaded, you can see the function is already there. So we have read underscore R, and it is telling me it is in the library read R. So I'll select that by clicking enter. Up to that point, are we all together? Have we loaded our library and have we started to that point read underscore CSV? Kindly, are we all there? So I've shared the data set. Should I give you a minute to have it on your device? So do we all have our data set? Kindly. Let's start with Moses. Oh yeah, I see Moses is saying thumbs up. Safe, you can send a signal as well. And Mary, okay, I can see Safe is also good to go. So Mary and Amina, do we have the data set in our laptop that is not just on our mobile phones? Do we have the data set? Mary and okay, Amina is good. Mary?
Not yet.
Okay, we are giving you 0.5 minutes. Those are 30 seconds. Yes, Mary. We have 1 hour.
You can continue.
Sorry?
I'm okay.
Are you okay or you have the data set?
I have the data set.
Okay, this is very crucial because in most of the cases you will always have to import your data. Now that we have all our data set, this is the procedure. One, you give it a name that you'll be using in R. And most of the cases, we'll just name it as it is in the CSV file. Now, after writing the read underscore CSV function, in this bracket, we need to have the path. That is the path to your dataset, where the dataset is located. Now, the advantage of setting a working directory as the folder where your data is, you don't have to paste to have all that path, but just the name of the dataset and the extension. That is, it's a CSV file and such. But now that we didn't set our working directory to where our data resides, we need to have that path. So what you do, you go to that folder where you have stored your data. This is where my data is. I'll right click that and go to properties, and I have the location. This is the path to my data set. So I'll copy that path, come to my R. Inside the CSV, the read underscore CSV, I pass that path. Now R does not understand the backward slashes. So there are two options that you can do. You either put them as double backward slash, or you change that to a forward slash, and most preferably is to change them to a forward slash. So we are changing that to forward slash. Now after changing, you see that is the folder, the final path, the folder that where our data set is residing. So when you go to that folder, maybe we have several CSV files. So you need to have the name. So I have the name of that file as data. There could be several, and even if it's one, you need to have the extension. So it's a CSV file. It's a CSV file. So what read.csv file will do, we'll go to this path and look for the data name, for file named data, which is a CSV file. Now, because this is like a statement, or rather, it's a string, we need to quote that. So actually, I should have started with the quotation. This one is supposed to be in a quote. So I should have started with a quotation, but we can actually copy that, or rather cut that and paste it. So it is supposed to be in a double quotation like that. And now I will run that. And you can see it's running here. It is saying stop, meaning it's running. So once it stops running, it means my data has been imported. And actually, this is confirmed by the fact that on the environment, I now have a new data called data1 with 100 observations and 7 variables. So now, when I come back to my R code editor and call that data and I execute that, it's data1 actually, not data1, and now I run that, it will give me this information. Now before we even talk about what is displayed on that data, do we all have our data imported, and we have called our data to have this information displayed about the data. Kindly, let's confirm. So starting with Mary, you can signal us if you have it. Let's just look at our data, the way it has been imported. So when we run, we call the name, you realize there's this information that is displayed. And first thing is, it's telling us it's a table, and it has 100 observations and 7 variables. Now, I was just saying that a table is just like a data frame. It's a data frame actually, but now it prints the output more structured. You can see we have actually a lot of information, or some useful information that makes us understand about the data. Like we have weight. These are now the variables, weight, quality, and all that. These are the variables. Down here, we have we can say the data types of the variables and some few observations, so that we can see how the variables are, or rather the observations are. And it is telling us there are 90 more rows, meaning this is just a part of the data set that has been opened to display, so that we can have some idea of how our data looks like. We can also use the view data that I was telling Mr. Moses to run. This now will give us our data, the entire data set. And you can see it's a table, and we are seeing all the observations there. So we can use the view to view that particular data. That is one thing that we also need to understand. Now, in most of the cases, because you see the data, the table is actually very nice compared to a normal data frame. So now and then, as we import our data, maybe we have used read.csv, and we want to maybe change the data frame not to a table. We actually have a function that can do that, and this function is called as table. So you just say as underscore table, and you change that. But now this function is in a library, and the library is table. So you first have to install that package table, load the package, and make use of as table. So like for this first one here, we have this data. This is a data frame, my data. We can actually convert this normal data frame to a table. So I'll say library table. Now you need to have installed, I'm sure I have installed this. So when I run that, it is already there. So now I say for the data, my data, which was a normal data set, I want now to convert this my data to a table. So I'll say as underscore table, and the function will appear. Now in that bracket, you pass that data frame, and the data frame is my data. So when I run that, my data, which was a normal data frame, has now been converted to a table and still retaining its name. So when I now run my data, or rather call that, it will give me as a table. You can see it's now as a table, like initially where we were having it as a data frame. So that is one way to convert. Mr. Moses, back to you.
Yeah, I think my problem is still persisting, so maybe you can sort it out with you later because time.
Okay. Later we can do that. But I would really like to see your screen and try to resolve it. But there's no problem. We can resolve that because
You can still do it if you insist.
sorry.
I can still present my screen if you insist.
Okay, I see also Mary saying something. Oh, Mary is saying she's experiencing power breakdown, no? And she's really crying. Sorry for that, Mary, but you don't worry. You can watch it. You can watch the video now, no, because you're watching a movie. But maybe we won't cover that much. We will stop around this. Now, okay, Mr. Moses will be back to that just in a few minutes because actually I want also you to try this. There are other methods that we can import data in R because we can import data. Actually, let me now focus on importing data and talk a lot about this. Not just talking but doing. We can actually use what we call, we have some procedures in R. Like when I come on the environment or on the global environment here, you can see there's also an option to import data sets. Everyone can see this here. And from here, I can import from text-based, from Excel, SPSS, SAS, and from Stata. We can also see that. The same way, if you navigate to files and I go to import datasets, so that is just like a shortcut of this. From a database, from read R, Excel, SPSS, and Stata. But what you need to understand is that whatever you will be doing from there, you can actually use a command. You can actually use a command to do that. So, suppose I want to import an Excel file. Instead of writing commands, I can run a procedure from here. Now, what I want us to do, the same data that I've shared, the same data that I have just shared, convert that data to Excel. This is what I mean. You open that data set because it is a CSV. After opening that data, now you go to Save As. And now you select Excel workbook. You select this location and you save it as an Excel workbook. So you select where you want to save your data, and then on this pop-up, instead of comma delimited, you select Excel workbook, and I save that, and you save that. So we have not the same data set, but now as a CSV, Excel, that is SLX extension. So now we go back to our R. Just a minute. We go back to our R here. Now we can actually write procedure to read Excel, the Excel file. But now instead of writing those commands, we can use this shortcut. We can say import and we say Excel. You click there. But I know to read an Excel file, I need to have installed the read XL package. I need to have installed this library. So it's like as you navigate, the path will be copied here to where it's saying null, and it will generate the command as it is required. So I'll browse and navigate to where my data is. So it is in desktop folder called R, and it is Excel. So you need to distinguish. The one for CSV is having an A, and if I put the cursor there, it will tell me. So I'll say open. Now you can see it has created the commands here. I can even copy those commands, and it is giving a preview of the data, and I say import. So it has imported and actually viewed the data, because the last command is view data. So I'll close that, and now the data is named data, and it is an Excel, and it is here with 100 observation and 7 variables. Now, because I've copied the commands, at times you are required maybe to share your R codes. I will paste them on my script. So instead of writing a procedure, writing these commands, we have actually been able to import this data using a procedure. So I have read the library XL and use the Excel, that is the read underscore Excel. The path is there and the extension, and the data is loaded, and I've viewed the data. What I'm expecting for most of you is an error, because maybe you had not installed the read XL. So before you can run the procedure, first you can install .packages, and you have it. You can run this first, install .packages read XL. You can first run that prior to the procedure, so that now it can load the library. Moses, what is the response for that from your end?
My response from my end,
yes,
is that the packages are installing.
No, we need to wait for you. Now at least this one should work, as we will resolve the other.
Yeah.
Amina?
It's fine.
Sorry?
I had the package.
So you have the data set as well?
Yes.
Mr. Saif? Mr. Saif, I hope you have it.
Yes, niko sawa.
Okay. Mary, maybe you tried using your phone. It's so unfortunate. So we are waiting for you, Mr. Moses. We'll be installing a number of packages. I said I'll make a list of those fundamentals that we'll be using. That you see now, unasema shughuli na masaa. But we'll maneuver, we'll just do it. You don't have to worry. We are here for 3 months doing this thing. You guys should be pro by then. Yes, Moses?
Yeah, I think I have the right track now.
Do you have the data? Now that you can rerun the procedure, if the library is installed.
Yeah, just a minute.
As we are waiting for Moses, you can also install the package called Heavens. That is the one we'll be using to import SPSS. I guess we shared that this is the library. You have an SPSS file. Most of you guys who have been together in the class of SPSS, and I'm expecting you have one. So install that package as we wait.
Yeah. Mine is full now.
Yours is okay.
Yeah, I have the data.
How do you feel that the data is in R? Okay, that is nice. So you can install that package, Heaven. You'll be using that to load your data for the case of SPSS. So you see, all you need to know is the package, because you need to know the function actually. Which function am I using to import this kind of a file? And when you do, the package. And then now you install the package, load the package, and write the function. Just assign it a name, then the function to import, and also the path. Most importantly, the path and the extension, because this is the path. But we also have the shortcut. Like if I want to import an SPSS file, and so from SPSS, you see the package is Heaven, and the data set is read underscore SAV. That is just an extension of the SPSS file. We were talking about that when we were doing SPSS. So then I'll browse to where I have. Now I don't know Mr. Moses if was having any, but that is not an issue. The most important thing is to know the package and the function. So I'll go to where I have my SPSS. Let me check. I guess I have one here. Okay, let me use this vehicle. So you see, basically these are the commands. I normally copy them for the case of documentation, but I prefer writing. This is just to show you an alternative way. So the most important is the library and the function, because this path you'll be copying it from where the data is, and in most of the cases it will end at SPSS, that is the file. Now this is the name, safety, vehicle safety, and dot CAV is the extension of the data, or I mean the file, the data file that is, and you can see it is what is here. So I say import, and my data is imported. I have actually been installed most of these data set. Packages. Most of these packages are installed from my end. So that is the data set, and I'll do the same for stata and all other types of data. So you see what is different is the package and of course the function. And actually you see, like this one is also Heaven, the library, and the extension read underscore. No, the underscore is for the extension. So for stata is stata and all that. So you can import any data set. Oh, one important also is that at times these guys will give you a data from a URL link, URL, and they are expecting you to read it to R. So how can you do that? How can you do that? Now, what you need to understand is that the first thing is that data set I'm reading a CSV file, or what kind of a data file is the extension. So once you know that the kind of the file, everything else is just the same. Now instead of having the path from the folder, I now have the URL. Maybe I try to get an example maybe of a data. Okay, we have this. I've been showing you this. So I'm back. I remember when I was in high school, there was this book. I don't know if it was a book or what. It was in primary school. Someone said, oh yeah, the title of the book was it a title or what? Going, I don't know where to. Okay, let's just forget about that. I'm not a good storyteller. So we want to read data from a URL link and all that from the cloud and such. So how can we do that? Now I was saying the first thing is to understand the extension of your data. So there's this one site I was showing you, that is the Kangol. I like using it. There's a lot. So Kangol.com, there's a lot of data and a lot of reports, a lot of codes. People are doing projects there and a lot of things are happening. So you can actually get data from it. It could be a GitHub or a GitLab of someone and all that. So, okay, there is like the housing data. Let's say the housing. There's a project on housing and the data. Let's just check housing prices. Let's say this. So we want the data. So data, and they're saying data card. Let me just see. Yeah, so this is the data, housing, and it's a CSV. So I want to see if I can get the URL to this data. How can now I get the URL? On a serious note. How can, just a minute. So I'm trying to get a link from here. I'm not seeing this. Okay. There are not sessions here. What is API command? Is that the link? Oh yeah, I think it is. No, it's not. So I'm trying to get the link, or someone is having a link, but I have, now it reminds me, I have actually a link somewhere. I have a GitHub. Let me just send it to you. So check on your chat. These things at times you need to relax and remember things. Check your chat. So we want to read a CSV from a URL. So I can even have a comment and say import data from URL. Now you need to know, is it a CSV file or an Excel file? So it's a CSV file. So I can call it Almond. Now Almond is a CSV file. I'm not going to use the underscore. Let's use the read.csv. read.csv. This is a function that is in one of the base packages. So we are quoting, but this time round not in our machine, because it is not in our machine. So we are actually having that from a link that I've shared on the comment on the message. So we copy that link, copy link address, then come to our RStudio and paste it. So we are to import our data from that GitHub account, and we run. So when we do, we can now actually call our data almond, and we run that, and you see that is a data, very small data about our players. We have player A, B, C to E, and the assists and the points. So we can read as a very big data as possible from the URL. So you can see we are only changing the path. The path is what is changing. Now, apart from, we were talking about the table. Let's going back to table, because I was saying that is very fundamental. The table is actually displaying some useful information, and also there are some important functions that we need to know, and we'll always use them to give us some information about the data that we are interested in. Now, before we look at this function, but of course we'll look at them, I want to talk also about, we're talking about libraries or these packages, and we're saying these packages are storing functions that we can use as well as data that we can also use. So what are some of these data sets that we can use? Now, the other day when we were introducing R, I know our time is up, but we are just taking like 10 minutes to finish this. We were actually importing one library called ggplot2. Now, ggplot2 is one package that will be mostly used in data visualization, creating beautiful, not just charts, but beautiful and awesome charts. It's a very powerful package when it comes to data visualization in R. And remember, in our advanced, our last part, actually not advanced but intermediate, our last subtopic is data visualization. So we will take a lot of time talking about ggplot. But at this point, it is important to know that the ggplot, just like any other package, it stores functions as well as data sets. So let's run this package so that we can get to know a data set of data sets that are there in ggplot. And one of famous data set that is mostly used is what we call the MPG data set. This data set is found in the library ggplot2. That is why it is we first have to load the library, then we can access the data set. So when I run the MPG, it will tell me that it is a table with 234 observations and 11 variables. Now, generally, this is not always important. Whenever you import the data to R or you are using inbuilt data, it is always important to do the following. Like number one, you need to look at the raw data to see how the data is. Maybe there, to understand, like it's like an inspection of the data. Maybe there are missing values. Maybe there are, you try to see the data set. Now, as you see the data set, the second aspect is to understand the data. Understand what, like for instance, where the data came from. Where is this data coming from? Like, what are the variables that are there? As you understand the variables, you understand their data types and data of those variables as well. So you get to understand the data. And most importantly, after you have checked your raw data and understanding the data, you do a visualization to understand what is being represented, to display information and insights of the data. So whenever we use inbuilt function, there is a lot of information that we need to understand about the data. And one important is to understand where the data came from and what are the variables that are being represented. Like, look at this. We have years, we have manufacturer, we don't know what is a manufacturer, is a manufacturer of what. We have model, we don't know what is the model representing. We have CYL as a variable and all that. So for inbuilt data, of course, for data that you have imported, you would have been given what we call data documentation. But now for inbuilt data, you need to ask for data documentation. So the same way you are asking documentation for a function, you do the same. So I'll put a question mark and run that. And when I do, it will give me on the help, it will give me the documentation. It is telling me this is the fuel economic data from 1999 to 2008 for 38 popular models of car. And you can see for each variable I have a documentation. So actually the model, the manufacturer is the manufacturer name of the car, the model name, the display is the engine displacement in liters, the year of manufacturer, the CYL is the number of cylinders. You see, now you have a documentation and you get to understand your data. That is one. Two, we also have those functions that I was telling you that are very essential. Like we have one function which is called the head. And this function is found in the util library, one of the basic packages in R. Now this head, when you run this, let's say we are running this for MPG, and we can even put a comma and specify the number of variables observation that we want to display, let's say 10, and we run that. Now basically, when you run the head function, it will display the first n now is the number of observation of the data frame, because this is a data frame. Now the head function will also display more useful information, like the data, the structure of the data, the number of observation, and also the number of variables that is now for head. So it is displaying the first 10 observation because we have actually specified that we want the 10 observation. We want the 10 observation. Now this function actually is nowadays mostly not used as such because of the concept of table. You realize when we call the data and it was imported as a table, it will give more or less the same information. But it was commonly used because before the read underscore CSV, when we were having the read.csv, it was actually mostly used. Another function that we have been using is the structure, to know the structure of the data set. So when I run structure mpg, it will also give me the data type, the number of observations, and the data type of each and every variable, which is also can be obtained from the environment as well. That is also another important function. The structure function. Now, maybe at time I only need to know what are those variables that are there in this inbuilt data set or the imported data set. We can also use what we call the n or I mean the names function. You see, we have the names function, and it's actually in base R. It is in the base package. So when you say names and then you pass the data set, it will give you all the names of those variables that are there. So you can see I have all the names. That is also one important. So most importantly is now how to access the elements. We can use the $sign. We can use that. So that for this case, I know I have years as one of the variables. So if I want to get the years, I can use the $sign and say mpg. Here I can say mpg, the $sign. And you see when I say years, it will give me the number of years, and it is from 1989 all the way to 2008, if I'm not wrong. So that is it. We can use that. Remember, we're also running the dimension. It is basically the same. The dimension, the number of rows, the number of columns to get such information. Now, when we were subsetting, this is also very important. I think this is the last thing we need to discuss because people are tired, and we put a pause here today. So when we are subsetting, like whatever we were discussing when it comes to subsetting, we are actually subsetting an entire observation. I mean an entire column of observation. Maybe like for this case, we are taking one variable, and display all that. But what if we want a portion? Maybe we only want to get the information about those cars from 2008 to, let's say, 2007 if they search. Are you seeing that? Or maybe we have highway miles per gallon. So let's run mpg and then miles. That is highway miles. So when we run that, you can see we have 29 several values, and I can see we have 30s and all that. So suppose we want to display all that information for those cars whose highway miles is actually greater than a certain specified value. We want to get the information to search. So you see, we are now subsetting, and it is becoming more interesting because we don't want the entire information, but just a portion of it. So that is one key aspect that we need to look at. So subsetting data frame can work much like subsetting matrices in this context, where we are using the square bracket, the name and the square bracket. Now remember, when we were looking at matrices and we were subsetting using the square bracket, we were specifying, when we are having the square bracket like that, we are putting a comma. Now this is the number of rows and the number of columns. So we are using a more, less the same approach. We are now the number of rows. In this first case, it's not really the number of rows, but in this first case, it is the number of observations that we want them to appear in our case. Let's say I want only those observations, like for this case, that are greater than 25. Now the question is, after you have all that have greater than 25, those observations, which information do you want us to display? Now that is, maybe you want to display the manufacturer, the year, and all that. That is what we want to do. And that is why we are bringing the aspect of like subsetting in matrices. So you can use the name and that information. So out here, I'll have mpg. Now, the first case where we are specifying about the rows that we want to access. Now, let's say for this case, we want the highway miles to be greater than, let's say, 25. So I'll say MPG, now $sign, the highway miles to be greater than 35 or 25. We say 25. Now the reason as to why, you see, this one is to access everything, but now this one we are using to specify. That is why again you need to specify which column you are using. So it is highway miles in MPG. Then I put a comma. Now after I have gone to that row, specified for that particular observation that you want, that is greater than 25. What information do you want me to print for that? Is it for the entire other columns, that is the model, the display, the years, and all that? If you want all other information, then you don't have to single out. You can just put a comma and run that. And when you do, it is giving you information of the manufacturer, model, display, year, and the rest for those cars whose highway miles is greater than 25. For the other case, it was giving us all information for all highway miles, but now it is only for the case where the highway miles is greater than 25. Maybe we are not interested to get all this information, but we only want to get the manufacturer of those cars whose highway miles is greater than 25. So how do you do that? Now here instead of selecting for the entire, you can just say I want the manufacturer. Remember, you have to write it as it is in the column name. So manufacturer, like that, and I run that, and you see it is only giving me for those cars that are greater than 25. It is giving me the manufacturer. It is giving me the manufacturer. I don't know if you guys understand that. Maybe I need to also retain the first code so that you guys can see the difference. So I'm getting for the manufacturer. What about, I'm not only interested in getting for the manufacturer, but also maybe the manufacturer and the model and the year. Now you see we need more than one attribute. So we need to use the combine function. So then I say manufacturer, I put a comma, and then I say the model. Also I put a comma for that, and I say a year. This is the last thing we are doing on this. And when I run that, okay, there's a problem. I bet it is a spelling mistake somewhere. Okay, I didn't close for the combine function, so I ran that, and now it has added more information. But remember, it is for those who highway miles is greater than 25. Is greater than 25. Guys, do we understand that? Do you guys understand what I'm doing? You can just signal or say something. Say, are we together? Amina, Moses, and Mary. Mary, even if you're following, you can also send a signal. So do we understand what we are doing? Or you guys are dead asleep? Yes, I can see Safe is saying thumbs up.
What you are saying.
Okay, there is no. Moses.
Yeah, I'm following.
You're following or you understand? You see that?
I'm following.
Okay, Moses. So maybe as we finish on this, you realize this is the beauty of using a programming language, then doing this type of analysis with other softwares like SPSS and the likes. There are several ways that we can actually use to do whatever we are doing. Like now, instead of, this is one of the best way actually, and a simple approach that we can subset and get the elements of a data frame based on a specific condition, because this is like a condition. But we can actually also use what we call a subset function itself to subset. So there's a function that is known as subset. So I can use this function to do the very same. And this function is called subset. Now, what are we subsetting? That is the question. Remember to always ask for help if you are not sure about the function. So you can check the documentation. When you run that, it will give you the documentation if need be. But for me, I ask myself questions as I implement the function. So subset. The first question is, what are we subsetting? The data frame MPG. I put a comma. Now, what is the condition we are using to subset? So subset using, that is the logic now. I'm defining the logic. Subsetting where the highway miles is greater than what? Is greater than 25. Is greater than 25. And I put a comma. So if you want all, you leave it. So that the first command will be like that. This one here can also be done this way. So when I run that, it will give me that information. It is for selecting for all. Now for the second one, I'll add manufacturer here. And for the third one, I'll add all this information. But you need to tell it what to select. In this case, you see we are using the function as a prototype. So what are you subsetting? I need to say subset equal to define the logic. Now suppose I want only the manufacturer, not the entire information. Let me just copy that. I'll have the same function subset. Now here, I'll have to say select to specify now what I want to select. Now in this case, because it's a function, and because it is only one, I'll say select manufacturer. Now because I'm lazy, allow me to just copy this. So I'll copy that and say select manufacturer, and I run that. So you see it's the same thing. It is doing the very same. Again for the last one, I can just say it is just the same. We're now just adding the last part from here. So that is how we can use the subset function instead of using the address alone. I mean the square bracket like we are doing for matrices. So then I'll say select for the last one, and I say select, because they are multiple, I'll use the combine from function. I copy that because I'm lazy, and I paste it there, and I run that, and it is giving me the desired output. So that is another approach. There are several approaches. Maybe, I had promised to look at what we call the pipe operator. This is one of an operator that we'll be always using when it comes to R. This operator, the reason why I want us to use this operator because there is what we call, you realize whatever we are doing from this package, this dataset MPG, we are filtering some information based on where this is used to filter, and now this one is used to select. So actually in R we have the filter and the select function from a package known as dplyr. This is another function that we'll be always using most of the cases, because it forms one of the basic functions when it comes to data manipulation. It is called the dplyr package. So the dplyr package has filter and select function. Now we also have the pipe operator. This is the operator I've been talking about. This is what we call a pipe. Now this operator is called in what we call the Magritte package. Now combining the filter and select function with the operator, the pipe operator, now will enable us to do all this. And actually this is the standard and the most used method that we normally use to select, or rather to subset and filter and select some information using in R. It is widely used and will always be using it. So I want us to finish by looking at that, which is actually one approach that we can use. But because of time, we are not going to do for all the three, but we are just going to implement for the last one, where we can select that. So to do that, we first need to load the library. So for this case, we are loading the library dplyr. I don't know if you guys didn't install. I know now you know to install. You just say install and you quote the name of the package, the dplyr. If you have not, you can also check because of time and then try to do it on your own. So when I run that, you realize it has also attached some packages that it is working along with, so it is good to go. Now what we do, this is how we implement it. So we are subsetting some information from a data set, a table for that case. So the first thing, I need to have the data set, the MPG. So I need to make it available for every other thing that will follow. That is why I was telling you the pipe operator is somehow like the attach, making something available. So once the data set is there, pass this data set using now the pipe operator to the next analysis. We are making it available. Now we have this data set. We have made it available. So what's next? From that data set, filter. Now the filter function, you can see I'm able to use it because it is in the dplyr. So I'll select that function. Now filter from this data set that has been made available by this operator. Filter where the highway per miles is actually greater than 25. Is greater than 25. So we are using that. Now after you have filtered that, make it available. Again, we are using the pipe. So we have made the data available and filtered. Now it's like we have a subset now of the filtered using it. Now using this. Now that what has been filtered, make it available using the pipe or pass it to. Now the other function, we are now selecting. Sorry. So we are passing that to the other function. We are now selecting. What are we selecting? we are selecting the manufacturer. Now, because we are passing these arguments to a function, direct to a function, you are not quoting. So we are saying select manufacturer. You see, now you can even see they are being made available, and I just need to click enter. Why? Because they were here in the MPG dataset. We have passed them to the filter function, and they have been filtered based on the condition that the highway miles is 25. All those characteristics or those columns have been passed to the select function. Now, whatever I'm trying to do here is already here. Whatever I'm selecting is already here. That is why when I write model, you can see the model is appearing there, and it's saying it is model from MPG because it has been passed, and I put a comma, and final I have here. You see, it is already there because it is passed, and I select that, and when I run that, it is giving me the very same information as we are using the other procedure. Now this is using the pipe operator, the filter, and the select function from the deployer function, which is mostly used and will always use it. So you can see all the three approaches here, they give us the same results. Now how you are going to use this, which approach you're going to use is based on you, and also situation, like the type of analysis. The beauty about using this pipe operator here is that whatever you select, you can pass it next to the other analysis and all that. Like for this, for instance, if I want to use this a subset in this case, then I need to give it a name, then access using a name. But if I was to use whatever has been selected here, again, I can pass it using the pipe operator. You see, that is the beauty now, making it available and all that. So that is it, and that is what a data frame is all about. Remember, in this context, it's a table, and it's basically just a data frame that is more organized. So any question? Any point that is not clear, and any question up to this point? Guys, did we understand that? Or guys are dead asleep? I see Sefer say thumbs up. Yes, Amina?
I didn't get the pipe operator well. I mean the understanding. I've not understood.
You should have.
Pardon.
You should have understand that because it is very useful. Yes, Moses.
I think we should have a recap of this last bit tomorrow when the minds are still fresh.
Oh yeah. So that is okay. Amina, don't worry. I know we are very tired also, and it's very late. So what you can do right now, make sure you have. Okay, we are using inbuilt data, so there is no problem. We'll have a recap from here. We'll continue from this point. So as we wait for tomorrow, kindly try to go through, and then if you also have another area that you didn't understand well, you can also ask. So Amina, we will redo the pipe operator tomorrow. Now, Mary was not even participating at all. Okay, she was here actually, not that she was not participating at all. Let me